All right, looks like we're live. Give me a plus in chat if you can hear me. Let me know if my mic sounds okay. Hello, Lisette. You got here in first. Chloe, Mystic Cities of Stories. Mookie, Purple VR. Welcome, welcome. Love to see you all in the chat interacting already. Love the energy on this Labor Day. Hope you had a nice day off from school today. Y'all looking amazing. O Star O. Hi. Samiha, hello. Chloe, hi, hi, hi. Yo, what's up, everybody? Does my mic sound okay? Does it sound okay? Hopefully it does. I can raise the gain, if anything. Still working some things out. This is our live stream, our live free stream on geometry today. We started our live lessons last week, actually, with grade 6 through 8, basically pre-algebra and algebra 1. If you're returning, let me know. But I see some new names here today, so really excited to, show you what I have planned for you today. Really excited for you to hopefully start your journey with me at my Headspace. Sounds good. Awesome. Thank you, Chloe. Today, we're going to be talking about interior and exterior angles. But before we get into the lesson, let me tell you a little bit about me. I'm Eddie. I am the senior math teacher at my Headspace, and I've been teaching for about 9 years. New Chloe, awesome. I've been teaching for 9 years in high schools and colleges. I've private tutored everywhere from 6th grade math all the way to students preparing for grad school. I did really well in school, got A's in a lot of my or all my math classes. I don't know why I said a lot of, but all my math courses. I got a perfect score on the SAT, and I got into my dream school, UCLA. After graduating from UCLA with a bachelor's degree in math, I started teaching right away. My students did super well. They got into the top universities. They've got 5s on their AP exams, exceeded the standard on state exams as well. But most importantly, they had fun while achieving their goals. And that's what I'm here for you today. I think math should be fun and approachable for all. And I want to guide the next generation of math geniuses, which is all of you on the other side of this screen. So I hope to have a lot of fun with you today. We're talking about interior and exterior angles again. But before we start, if you could copy the URL at the top of your browser and share it with, your friends, let them join on into this chat. Let's make this chat pop off today. Start that hype train. And I'm looking forward to, let's get into it, right? Why wait? Let's get into it. New as well, Samhyuk. Welcome. Welcome. I hope I'm pronouncing everyone's names correctly, by the way. If I'm not, just let me know. I know it's really hard to let me know how to pronounce it via chat, but I'm going to try my best. Let's get this party started. So, I love to start my lessons off with a vibe check. So, let's talk about this. In the chat, name all the ways you think these two images can be related. So in this first image, I kind of see, looks like someone hammering a nail into wood. Could be like construction work, could be just, building homes, building furniture, really anything, just something DIY, but it looks like a pretty big nail. So it looks like they're hammering in some, thicker wood, maybe creating a bench of some sort or anything like that. In our other image, it looks like baseball, right? A batter hitting a ball, and it looks like they made contact with that ball, which is really, really hard to do. I don't know if any of you love baseball or watch baseball or have played baseball before. But yeah, it just looks like a baseball batter hitting a ball, making contact. And it looks like there's a lot of force being put into that bat as well. So name all the ways you think these two images can be related. Any ways these two images can be related? Well, to start you off, it looks like there's wood in both of these images, right? On the left image, it looks like the hammer, we're nailing a nail into the wood, and then the baseball bat obviously is made of wood. Hasana, hi, welcome. Hi, Vanny, welcome to the lesson. Thank you for modding tonight. Plywood, yeah, it does look like plywood. How many times he swings the bat or speed it's going? Oh, that's great, Hasana. Great observation. Both take practice and dedication to do. Wow, Mookie. Yes, just like mathematics, both take practice and dedication to do. I love that. Both apply force. Ooh, someone might love physics in here. Use of force. Yes, Purple VR Chloe. Same wavelength. Y'all use telepathy or something there. Both need force and precision. Nice, Danu. Welcome. Same wavelength again. I mean, thank you for being here. Force, yeah. A lot of these require force, and I really like that. But the main thing here that I would like to chime in on is that we're talking about angles today, interior and exterior angles. And both of these forces, let's use what you told me today, hammering in a nail and batting or hitting a baseball with a baseball bat requires some type of angular force. So they need to both be hit at a certain angle to be hit correctly. So that's what we're going to be talking about today, interior and exterior angles. Points of contact, exactly. Points of contact might be used as maybe vertices of a shape that we're going to be using today. Before we get started, I want to make sure everyone is on the same page and able to access today's information, today's lesson. So here's some prior knowledge that you have to know in order to be able to access today's lesson. The angles in a triangle add up to how many degrees? Let's start with that question in the chat. If you know, let me know in the chat. The angles in a triangle add up to how many degrees? Remind you that a triangle is a shape with 3 sides connected and make 3 interior angles as well. So I see Danu already giving us a head start here. 180 degrees is correct. Let's write that down. 180 degrees. 180 degrees. Let's get the answers coming. Chloe, Salome, welcome. 180 as well. Awesome. 180 degrees. Now, next question. How can we prove that the angles in a quadrilateral add up to 360 degrees? Well, Alfredo has an idea. 180 times the number of sides. Wow, we're getting somewhere. Let's think about this for a second. For a quadrilateral, let's see if Alfredo's correct. It's freezing for Mr. Is it? Oh, am I freezing? Oh, that's not too good. Hopefully that gets better. Let me see. 1 second, really quick. Okay, cool. For me, maybe try refreshing the stream and it could possibly work better. Awesome. By the way, I love the enthusiasm in chat today, the participation. Let's keep that up. Love it. So how can we prove that the angles in a quadrilateral wow, hard word to say, huh? Quadrilateral add up to 360 degrees. Well, before our prior knowledge, if we had some type of rectangle or square, we cut the square or rectangle or quadrilateral in half, and we know that the angles in a triangle add up to 180 degrees. So we said, okay, we have 2 triangles here. So 180 degrees times 2 equals 360 degrees. That's how we proved that the angles in a quadrilateral add up to 360 degrees in the past. Now let's see if we can find the general formula with any shape, however many sides we have, however many angles we have. Let's try to find the sum of all interior angles of any shape by dividing them into triangles. And for this, Alfredo, I see you're on the right track. I love it. Let's keep this, and I'm going to draw some straight lines here. So let's try splitting. Let's try splitting each shape into separate triangles. So we have this. Oh, it looks like my lines aren't registering quite well. Let me try using my mouse. Oh, there we go. And getting this one. Oh, okay, boom, there it is. So it looks like for this first shape, we were able to divide them into 3 separate triangles. Let's actually go ahead and separate or divide all these shapes into triangles first before going back into the full screen mode. So here is another one. I'll try to estimate it as best as I can here. I know it's not perfect, but at least the lines are a little straighter than how they would be if I were to freehand these. So I'm going to start drawing these straight lines. And notice how I'm going from one of the vertices to the other vertices of the shape. None of these lines are crossing each other, right? All of these lines are coming from one vertex to all the other vertices. And so now with the hexagon, we see 4 separate triangles. Now let's try with the heptagon. If we insert some more lines here, boom, there's one. Trying to make it as accurate as I can. Insert another line. Boom, there's another one. And it looks like I missed one, right? In the middle here. Hard to see, but there is another triangle right there. Ooh, tricky, tricky. Almost got me with my own question. And up here as well. All right, let's go back into the full screen and see what this looks like. So, in a pentagon, we were able to divide this shape into 3 triangles. So what would that mean? We would have 180 degrees times 3, and that's equal to 540 degrees. Now, a pentagon, penta means 5. So we have a 5-sided shape, right? A 5-sided shape. Will this video be kept to view as a later? Yes, this will be, Alfredo. This is all being recorded, just like all my live lessons will be recorded, and more about that coming later. This next shape is a hexagon. It has 6 sides, and we can divide them into 1, 2, 3, 4 triangles. So what do you think we would be doing here? How would we find the sum of all the interior angles of a hexagon now? How would we be able to do this? Knowing that for the pentagon, we divided the pentagon into 3 triangles, and we multiplied 180 times 3 because we know a triangle, the angles in a triangle add up to 180 degrees, so we multiplied that by 3. This time for a hexagon, we have 4 triangles. So what should we do here? Let me know in the chat. We have 1, 2, 3, 4 triangles. The angles in a triangle add up to 180 degrees. How would we find the sum of the interior angles for this hexagon? Chloe, Danu, amazing. There's a reason why you're number 1 and 2 in the chat. Let's see if anyone can overtake you today. 180 times 4. Mookie, I see you as well. 180 degrees times 4. Beautiful. And when we do this, 180 times 4, we get 720 degrees. What did we just find? Awesome, Chloe. 720 degrees. Purple VR, I see you as well. 720 degrees describes the sum of the interior angles for this hexagon. Now let's look at the heptagon. There's a smaller triangle here, hard to see, almost got us. 1, 2, 3, 4, 5 triangles. So what should we do here? Right? Now that we've done 2 examples, for a heptagon, we can split up into 5 different triangles. What can we do here? Danu, amazing. So quick with it. Purple VR, I see you as well. 180 degrees times 5. Amazing. That equals 900 degrees. Chloe, awesome. I see you. Amazing work so far. Which would equal 900 degrees? Yes, Danu, amazing. Now, hexa stands for 6, 6-sided. Hepta stands for 7. Now, let's try to find a pattern here. Kushi, Purple VR, amazing. Great participation. Yes. Just echoing Vanny here. Said it before, or said it right after I said it. We're on the same wavelength as well. Amazing. We have pentagon, hexagon, heptagon. We have sides 5, 6, and 7. Does anyone see a pattern with what we did with the math? When it was a pentagon, 5 sides, we multiplied 180 times 3. When we had an hexagon with 6 sides, we multiplied 180 times 4. With a heptagon, 7 sides, we did 180 times 5. Now, I know a lot of you in the chat are already popping off here. Amazing work. I see Donna says sides minus 2 equals the number of triangles. Yes, the 180 is the same as well, Kushi, right? Every single time. Yes, Samia, 180, right? We're talking about how many triangles we see, and every triangle adds, the angles in a triangle add up to 180 degrees, and that's why all of these have that in common. Great observation. Now notice the 5, 3, 6, 4, and 7, 5. With each number of sides, it looks like we are subtracting 2. And that's the pattern that this always follows. The sum of interior angles for any shape can be divided into triangles and multiplied by 180 to equal the sum of interior angles. So let's take a look at this next slide, and we see the sum of all interior angles in a polygon are 180 times n, which stands for the number of sides or the number of vertices. Every polygon should have the same number of vertices and or sides. I see Kushi, Chloe, amazing. The amount of sides is always 2 more of triangle amount. Great, great observations. Now let's put this into practice. Now that we know that this formula is comes from the pattern that we just discovered, right? We just discovered this in our APK. So now we can use it for every single polygon here on out. So let's try this type of problem. Find the missing angle in each shape. So we're trying to look for x. Right now, how many vertices does this shape have? How many vertices does this first shape have? How many vertices or how many sides, right? The number of vertices and the number of sides will always be the same in a polygon. So if you were to count the number of sides for the vertices here, how many do you see? What is our n value going to be? Amazing. Danu, Mookie got 5. Hassan, I see you wrote 3, but I think you're just ahead of the game here. You've already subtracted 2 from the 5. Salome, I see you. 5, I don't know, maybe, Kushi? Yeah, I don't know. Maybe. Let's check it out. We have 1 vertex, or 2 vertices, 3, 4, and 5. You are correct. N equals 5. Now let's try with the sides. We have 1, 2, 3, 4, and 5. They are the same. So n is equal to 5 here. Awesome, Chloe. Now, if we have 5 as our n, let's plug it in into 180 times n minus 2 in order to solve this. Now, we have to keep something in mind here. We cannot forget about those parentheses. Because, Zaid, I see you. Because if we forget about the parentheses, we'd be multiplying 180 times the 5 and just subtracting a 2. We have to mind our order of operations. And so we say, all right, 180 times 5 minus 2. Well, 5 minus 2 is 3, and we just did this with our pentagon earlier in our previous slide, and that equals 540. Don't forget the degrees here. We always want to use correct units of measure, and in this case, we'll be using degrees for all angle measures in geometry until we hit radians later on. So now 540 degrees. I want to add up all of these other angles so that I can find x. Amazing, Chloe. How could I do that? What can I do to try to find x here? We have 540 degrees. We know that all these angles are going to add up to 540. So what can we set up to find 540? Amazing, Purple VR. I understand it more now. Awesome, Kushi. I love it. We're growing. We're learning. This is our growth mindset. You might not have known it before, but eventually, right, we're all going to get it. And by the end of this lesson, you're going to see how much you've grown, because the type of problems we're going to be solving at the end of this lesson, you're just going to be like, wow, I can't believe I just solved that. And all within just an hour. It's going to be insane. So keep up with me here and keep participating. That's how we're going to learn. Chloe, I see you. Right, we can subtract every single angle that we see from the 540 to get to our x value. Or Danu, add up all the angles besides x and then subtract from 540. You guys are on the same wavelength. I love that. Let's set it up. Let's write it down just like you did. So we have this right angle. Right angles are how many degrees, by the way? Just to make sure everyone's on the same page here. Right, whenever you see a right angle, what is that degree measure for a right angle? The degree measure for a right angle in the chat. Let me know. I see Danu says 90. Chloe says 90. Awesome. Any others? 90. Awesome. Great. Salome, Alfredo. Amazing. 90. Let's get it. 90 degrees plus, I'm going to go left to right here clockwise. I see you, Kushi. 125 degrees. Mookie as well. Plus 105 degrees. Plus the x, plus the 60 degrees, and all this, 1, 2, 3, 4, 5. Make sure you have the right number of angles here as well, will equal 540 degrees. And now we solve for x. We add these all up. I'm just going to do some really quick mental math here. 105 plus 125 is 230. Right? I just added these together. 90 plus 60 is 150. And we have this x. And this is equal to 540 degrees still. 230 plus 150 is 380. So x is going to equal 540 degrees minus 380 degrees, which is equal to 160 degrees. Now, let's make sense of this problem. When you look at the angle x here, notice how it's very close to being a straight line. A straight line gives us 180 degrees. And notice how this angle is very close to being a straight line. So 160 degrees makes sense. Awesome, Chloe. Awesome, Danu. I see you're following along. We always want to make sure the math makes sense. We always want to make sure the math checks out. So always, whenever you get an answer, make sure it makes sense, right? That's where the phrase make it make sense came from. It came from math class. All right, let's check this next one out. How many vertices do we have? We have 1, 2, 3, 4, 5, 6, 7. So what's the value of our n here? N is equal to, awesome, Mookie, 7. N is equal to 7. And therefore, Danu, you said 5, Chloe said 5, because 7 minus 2 will give us 5. I love it. I love it. 7 minus 2 is 5. So we have 180 times 5. We did this in our previous slide as well. This is equal to 900 degrees. And we are going to use the same method as we used in our previous problem to get the answer to x in this second problem. Awesome. I see you, Kushi, Purple VR, Zaid, Samia, Chloe. Awesome. So good. Let's keep it going. Let's add these up. I'm not going to write it out like this time. I'm just going to start adding up a couple of them that I know that I can solve just in my head. 139 plus 131. Well, that's going to be 270 because I know 31 plus 39 is 70 and 100 times or plus 100 is 200. So I'm going to start writing it up here just so my head doesn't cover the work. So 270 degrees. Now, 95 plus 111. That's going to give me, what does anyone know? 205 maybe? Because 110 plus 90 is 200. 4 plus 1 is 5. So we have 205. If you're not liking the mental math here, you can always use a calculator as well. No pressure. Plus 100 degrees plus 152 degrees plus x, and that will equal 900 degrees. Let's add these all up. This is going to be 475, 575, 675, and then we'll have 727. So x will equal 900 degrees minus 727 degrees, which is equal to 173 degrees. And that is our value for x. And now, does it make sense? You look at this angle, it's really close to being a straight line, which is 180 degrees. This is a terrible line, by the way. I'm actually going to redraw that because I'm not happy about that line. Let's draw a straighter line that's more representative of where this is going. And it looks like 173 should be correct. How did you get 270? Great question. I added 131 and 139. 31 plus 39 is 70, and 100 plus 100 is 200. I said add, right? Plus and not multiply. I keep thinking I'm saying times, but I mean add, right? Plus. Great question, Kushi. If you ever have any questions, please ask along the way. Oh, I see Danu, Chloe, Kushi, Mookie, Purple VR. All of you are getting 173 degrees. Amazing. Let's keep this show going. So now, it can get pretty crazy, right? It can get pretty crazy, and these are some crazy examples. So let's check this out. We're going to do these the same way we did our previous problems. So find the missing angle in each shape. Can everyone tell me in the chat, what is our value of n going to be? Without subtracting that 2 first. Oh, the shape, yep. What is the value of n for this shape? So right here, you're counting the number of sides. You're counting the number of angles. What is, give me the value of n for this shape, and then we can take a look at it together. And maybe I'll start, right? Here's the x, so that's where I'm going to start. Here's our first one. So 1, 2, 3, 4, 5. Wow, we're already at 5. 6, 7, 8, 9. Wow, 10 vertices or 10 sides. All good. No need to be sorry. I mean, this is a huge shape, right? So many vertices, so many sides. We got 10. So the value of n here is 10. I see you, Danu, Hasana, Purple VR, Chloe, Salome, Kushi, Samiha. Amazing. n is equal to 10. So let's keep this going. Mookie, I see you as well. So we're going to plug it in into 180 times 10 minus 2, right? N is equal to 10. So 10 minus 2 is 8. 180 degrees times 8. Man, what could that be? Well, 8 times 100 would be 800. And 8 times 80 will be 640. So this will equal 440 degrees. Just like that. Great start. Now, these are a lot of numbers. So I'm actually going to use a calculator here to help us out. On my calculator, I put it to scientific mode so that I can see everything that I'm adding. And here's a quick little tip here. I always start with the angle that's next to the x, because if I start somewhere in the middle, I might lose my place. But I'm going to use my x as kind of like a placeholder. This is where I started, and go counterclockwise or clockwise from there, whichever floats your boat. But this time I'm going to go to the right. So I'm going to start with 49 plus 130 plus 85 plus 271 plus 88, plus 154, plus 118. Don't forget that one. That one's outside of the shape, so it's easy to miss, but don't forget it. Plus 98, plus 241. Boom. And we get 1, 2, 3, 4. Wow, how nice. 1, 2, 3, 4. Now, from 1440, I am going to subtract 1234. I see Danu, Chloe, Purple VR, 1440. Amazing. So we'll go 1440. Let's go back to our full screen. We have, I don't like writing in red that much, so go 1440 degrees minus 1234 degrees. And what would that be? That would be 206 degrees. Awesome. Dana, you beat me to it. Kushi, awesome. 1440, I see you. Mookie, you almost beat me to it as well. Love that we're on the same page. Kushi, 206. Awesome. X is equal to 206 degrees. Boom. There it is. Next. Regular dodecagon. Now, regular. Does anyone know what regular means? Regular. If the word regular is in front of any type of polygon, whatever name of the polygon is, if we put regular in front of it, what does that mean? Zaid, Chloe, amazing, amazing stuff. Let's keep it up. Amazing work. Regular. All good. We're here to learn. Purple VR, thank you for being honest. Let me give it to you. Regular means that all the sides and all the angles, all the interior angles, the angles inside of the shape and all the sides are equal. Are equal. A normal shape with no abnormalities. Amazing, Mookie. That's a great, you explained it better than I did. Amazing. So all the sides are the same and all the interior angles are the same as well. So if this shape has 12 equal sides, yes, congruent in all sides, that's exactly another way to explain it, Chloe. We can say 180 degrees times 12 minus 2. Now this is really easy because this is just 180 times 10, which gives us 1800 degrees. Now we have 12 sides in this shape. So how many angles, how many interior angles do we think this shape has? In the chat, let me know. How many interior angles do you think this shape has, knowing that this shape has 12 sides? How many angles does this shape have? How many interior angles? Angles on the inside of this shape. How many angles does this shape have? Yes, Kushi, Zaid. Yes, 1800 degrees is the sum of all interior angles in this shape. Now, Chloe, good guess, 10. What did we do? Did we count? Not sure? 8? Let's count. Let's count. Let's start from here. Let's go 1, 2, 3. Oh, I should follow my rule, right? Let's start from, I mean, this time I'm jotting them down by number, so it's okay. But I always want to start somewhere close to the X as a placeholder. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 angles. Awesome. I see we got it at the end. Yes, 12 is correct. 12 sides means 12 angles, right? We learned something new today, and that's great. 12 sides means 12 angles. So now, in order to get x, what can we do with this 1800 degrees? This information, 1800 degrees again means that the sum of all 12 angles equals 1800. But what do we say about regular again? Regular means all the angles are the same. All the angles are congruent. Meaning, amazing, Danu. Amazing. 1800 degrees. Chloe, amazing. I love it. 1800 degrees divided by 12. And that will give us 150 degrees. You can check my math there. Divide by 12, Kushi, I see you. 150 degrees. And does that make sense? Well, if we create a straight line here, notice how this angle almost gets us to a straight line, which is 180 degrees. And this 150 degrees does in fact look very close to that. All right, now the next example here, the total of the interior angles of a polygon is 2,340 degrees. How many sides does it have? Makes sense, Kushi. Awesome. Oh, thank you for mentioning that, Mookie. Awesome. Love that. X is equal to 150 degrees. We always want to make sure we're answering the problem at hand. Thank you for catching that, Mookie. Extra credit for you today. Now, we have the total of the interior angles of a polygon. The total of the interior angles of a polygon. How did we write that before? We wrote that as 180 degrees times n minus 2. And they're telling us this is equal to 2,340 degrees. What should we do to find how many sides it has? I don't know. Maybe look for the unknown. In this case, maybe solve for n. So since we have 180 degrees times n minus 2, what if we divided both sides by 180 degrees? Thank you, Danu. Solve for n. So we have n minus 2 is going to equal 2340 divided by 180 degrees. Notice how the degrees, the units of measure, will also cancel out here. 2340 divided by 180, I'm going to give it to you here, is 13. So we have n minus 2 is equal to 13. So n is equal to 15 after adding 2 to both sides. Solve for n. N equals, hi Yi, welcome. N is equal to 15. Awesome. So we found that a polygon with the total of the interior angles of a polygon that is 2340 degrees has 15 sides. This polygon has 15 sides. Awesome, Chloe. Love it. Let's keep the ball rolling. Now, the interior angles are easy to work with, as we saw. They're very useful. That formula, 180 times n minus 2, that's a pattern that always works. But there must be a better way to do this, right? We want to work smarter, not harder. So if you look at this one, if you extend the line of any shape's side, you form an exterior angle as shown in the diagram. We did this a couple times. Now this green portion is called the exterior angle. The pink angle here is called the interior. Now, before I click on this animation, what do you think these 1, 2, 3, 4, 5 exterior angles, what do you think all these angles will add up to? What do you think these 5 angles will add up to? All the exterior angles of a polygon, what do you think that will add up to? Give me your guesses in the chat. Doesn't matter. Again, this is just a guess, right? I don't expect any of you to actually know this. This is the first time you're seeing this. What would you guess? Move into a pentagon? Maybe. Maybe. Possibly. 180 degrees is a great guess. 900, great guess. Right? We're thinking, right? We're thinking. We're making educated guesses here. 270, maybe. 360, 900, 180. Let's take a look. Zaid says 360. Let's take a look. I'm going to click on this animation and get ready for your mind to be blown. Boom. What shape do all those angles make here? What shape did we just make by clicking on this animation? Right? I'm just going to click it a couple more times because it's so satisfying, isn't it? It's like mesmerizing. We made a circle. Wow. And a circle has how many degrees in it? Let's go. Yes. 360. Yes. Right? Now we know all the exterior angles of a polygon add up to 360 degrees. Crazy. Yes, E. Thank you for verbalizing that. This is absolutely insane that it works this way. right? Math is insane. Now, so we're going to keep this. Oops, I accidentally. Okay, now we know the sum of an interior and exterior angle is 180. We just saw that. And the sum of exterior angles of a polygon is 360 degrees. Now, when dealing with regular shapes, mind equals blown. Awesome. It is much easier to work with exterior angles first. Now, if we know the exterior angle of a regular polygon is 30 degrees, how many sides does it have? Alfredo, I see what you're doing here. I love it. I love the way you're thinking here. The exterior angle of a regular polygon is 30 degrees. Oh, Danu, give us the answer straight. 12. Is that correct? Let's check it out. Oh, Yi also thinks 12. How did we get that? Danu and Yi, how did we get 12 so quickly? Right, before we had that 180 times n minus 2 crazy equation, but now it seems like we're getting this a lot faster. What did we do to get to this answer? Danu says 360 divided by 30. Kushi, I see you got 12 as well. Yes, if the sum of exterior angles is 360, and we know for a regular polygon means all the angles are the same. The exterior angle is 360. We know 360 degrees divided by 30 degrees will give us 12 sides. Divide by 30. Awesome. So what can we do with this next one? The interior angle of a regular polygon is 160 degrees. How many sides does it have? Ooh, creating a little bit of a twist here. I told you, this time I gave you the interior angle. If I give you the interior angle, now I need to find the exterior angle to make this problem easier. What's the measure of the exterior angle for this regular polygon? If each interior angle is 160 degrees, what is the value of the exterior angle? And let me give you a hint. Look at this first one right here. The sum of an interior and exterior angle is 180 degrees as they lie on a line. So if we know the interior angle is 160 degrees, give me the value of the exterior angle. That's just going to be 180 degrees minus 160 degrees equals 20. Where did the 30 come from? Great question, Hasana. 30 came from right here. We knew that the exterior angle of a regular polygon is 30 degrees. So if you look back to our previous slide, we're saying this is 30. And all these are the same, right? And we saw in the animation that these add up to 360. So if we divide 360 by just one of these, we'll get to our answer. And that's how we got the 12. We divide it by the exterior angle. So now in this case, I love these answers. Danu, Chloe, Kushi, Yi, Muki, got you. Thank you for asking, Asana. No question is ever a bad question. I will go back to make sure everyone gets it. So an interior angle is 160 degrees. So we got 20 degrees now as our exterior angle. Exterior angle is equal to 20 degrees. How many sides does it have then? Again, we will take our 360 degrees, the sum of all exterior angles, and we can only do this because we're working with a regular polygon. We'll divide by 20 degrees. Again, the 30 degrees came from right here, and the 20 degrees came from right here. This will equal 18 sides. Yes, let's add our units of measure here as well. Sides. Sides of our regular polygon. Beautiful work, y'all. Beautiful work. Let's keep this ball rolling. I'm so excited to get to our bigger questions that's going to absolutely blow our minds. Where did you get 180? Yes, the sum of an interior and exterior angle is 180 degrees. From our previous slide, you see that on a line, any two angles, three angles, any number of angles that lie on a line together will add up to 180 degrees. Amazing. So is the sides, 18 sides equal to n or n minus 2? Great question, Chloe. Remember, n always stands for the number of sides. Okay, n stands for the number of sides. n minus 2, remember, is the pattern that we saw at our very APK, right? At the very, very beginning. Good question. Great, great question. Let's keep this moving. Now, the exterior angle of a regular polygon is 24 degrees. How many sides does it have? So here, what do? We take, again, 360 degrees and divide that by 24 degrees. Let me know what you get in the chat. What's 360 divided by 24? We can use long division here, or short division. And we can go, okay, 24 goes into 36 once. Subtract, we get 120, and 24 goes into 125 times. Amazing. Wow. Danu, Purple VR, Chloe, Kushi, amazing. We have 15 sides. Awesome. Now, Yi, I see you as well. Amazing. The next one, the interior angle of a regular polygon is 175 degrees. Ooh. So what is our exterior angle going to be? We were given the interior angle. What is the value of our exterior angle going to be now? Knowing that our interior angle is 175, and we know that the interior angle and exterior angle add up to 180 degrees. Ah, great, Danu. Danu is way ahead of the game here. Give us some time. Just kidding. Amazing work. Since we have 175 degrees, we know the exterior angle will be 5 degrees. And Danu, share with us how you got that 72 sides. How do we do that? Since we now know the exterior angle is 5 degrees, how do we use this 5? Yi, that's amazing. 5 degrees is correct, right? Because 175 plus 5 gives us 180. Yes, Kushi, amazing. Yes, 360 degrees. Oops. I got too excited there. Skip the 0. 360 degrees divided by 5 degrees, and that does in fact give us 72, and this polygon will have 72 sides. Yes, exactly. Just divide. Awesome. Now, you can see how this is so powerful and so useful to know, right? All the exterior angles of a polygon equal 360 degrees, and still don't forget the sum of interior angles. Yes, dab, exactly. All the sum of interior angles is equal to 180 times n minus 2, n standing for the number of sides. Amazing work. Alfredo, I see you with that as well. That's another way to solve it. Yes, it all makes sense now. Let's go into some crazy problems. All right. This diagram, this first one, shows two identical regular pentagons. So I'm telling you, these 5-sided shapes are regular. All the angles are the same. All the sides are congruent. Find the value of the angle x. Multiple ways to solve this problem, by the way. Multiple ways. But again, here's the thing about math and geometry especially. You never want to just keep looking at the problem. You want to write something down. So first, what do we know about regular pentagons? We know that regular means they're all the same. 360 divided by, I don't know after. Yes, 360 divided by 5. What will that give us? Will that give us the interior angles or the exterior angles? If we do 360 degrees divided by 5, does that give us the measure of our interior angles or our exterior angles? From the previous ones that we did. Alfredo, great. Exterior, Chloe, Kushi, I see you guys are on it. Exterior is correct. So what if, Danu, I see you as well. If I extended this line, would you agree that this red angle that I'm drawing here, this red angle, would you agree that will be equal to 360 divided by 5? Right? Exactly, right? The sum of exterior angles adds up to 360. So if we divide by the number of exterior angles there could be, we could solve it like this as well. So 360 divided by 5, that is simply 72 degrees. Now, what does it look like x is going to be? X is going to be, how many times does this 72 degrees happen to get to our value of x? To get to our value of x, Chloe, how did you get that 144? That's correct, by the way. How did you get there? We know that this red angle right here is 72 degrees. Danu, I see you got 144 as well. How did we get there? Yi, you got it as well. 72 times 2. Amazing. Danu, Chloe, thank you for breaking that down for us. Purple VR, O-Star, amazing. 72 degrees times 2 is 144. So that's how we know x is equal to 144 degrees. That's an amazing way to do it. Let's just keep it like that, right? I feel like that's the easiest way to do this. Now, let's look at our next example. The diagram shows a regular hexagon times 2. Yes, sides are the same. Amazing work, y'all. Find the value of the angle x. How should we start with this? Well, we know that this is a regular hexagon. Mookie, I see you. A regular hexagon, 6-sided. 6-sided. Okay, well, if it's 6 sides, this time we see our Our previous example worked with exterior angles, but it looks like this time our angle X is on the inside. So what would be beneficial to find here? Well, if it's a regular hexagon, what is the value for our n? What is n equal to here? What is n going to be equal to here? If we have a regular hexagon, n is going to equal 6. I see you, Chloe, ahead of the game. Mookie, Danu, amazing. 6 is correct. So we have 180 degrees times the 6 minus 2. Great. N is equal to 6. So we have 180 degrees times 4, like Chloe said. So this will equal 720 degrees. We can use this information, nicey, nice Kushi. We can use this information to find the value of just one of these angles. Let's look for this one right here. How do we look for that angle right here? We can divide this 720 degrees by, nice purple VR. We can divide 720 degrees by the number of angles that we see, which is 6. Great, Mookie, Chloe, awesome. And this is equal to, stars ahead of the game, 120 degrees. Danu, Chloe also ahead of the game. Kushi, awesome. So we have 120 degrees. That's what this angle is equal to. Does anyone have any idea what we can do from here? If we know that that angle is 120 degrees, we're one step closer to solving for that x. What can we do? What can we do to get to x from this triangle that we see at 120 degrees? Amazing, Yi. Amazing stuff. So we have 120 degrees. We know that a triangle, the interior angles of a triangle add up to what? The angles of a triangle add up to how many degrees? If we have any triangle, if I were to redraw that triangle there, and we know this is 120 degrees, we know the angles of a triangle add up to 180. Amazing, Chloe. Purple VR, amazing. 180. So we have, since this is a regular hexagon, we know that this angle and this angle will be congruent. This is an isosceles triangle. Isosceles triangle. Nice, Kushi. Nice, Mookie. Nice, E. Amazing stuff, Star. Danu, I see all of you. Chloe as well. So we have this and this angle will be the same. So after we take out 120 from 180, we're left with 60 degrees, meaning that each of these angles will be 30 degrees. Amazing, Star. I see you're ahead of the game. Here's 30 degrees. Here's 30 degrees. I see you, Chloe, as well. So now, what is the value of our x? Can anyone tell me? With all the information we have now, how do we get to the value of x? X will be equal to that interior angle of the hexagon. And what do we do with that to get to this value of x? 150? Maybe? Add what? Give me more information. We know that this angle is 30 degrees. We know every single interior angle here will be 120 degrees. How do we look for x? How do we look for x? Add. How about we add 30 degrees plus x? Great idea, Yi. How about we add 30 degrees plus x, and that will equal 120 degrees. So what does x equal? What will x equal? Yes, Danu, 120 minus 30. Subtract? Yeah, subtract 30 from both sides. We get 9. Oh, amazing. Chloe, Danu, Star, amazing. 90 degrees, and that's what x is equal to. And does everyone see that this angle right here does in fact look like a right angle, right? It looks like a right angle. Beautiful work, y'all. I have 2 more questions for you, and you are in for a treat. Let's take a look. Again, it looks intimidating, but math is all about giving it a try, right? Give it a try. Write down what we know. So I'm going to try to model that here. I'm going to model this, and you can help me out along the way, okay? The diagram shows a regular pentagon. You can see it right here, the way I'm outlining. This is the regular pentagon with 5 sides. And a regular hexagon. Here's the regular hexagon. Right here. Right, here's the regular hexagon. And they're overlapping. find the value of x. So what's the first thing I'm going to do? The first thing I'm going to do is I know that for a regular pentagon we just worked with has a total of 540 degrees in it. We just worked with a hexagon as well, and we know that one has 720 degrees in it. And if we divide by the number of angles, the number of sides for each of these shapes, then we can get it, right? So let's take a look. If I'm going to do this in two different colors, for a pentagon, it has 5 sides. So if we divide, what is this? A pentagon, so 5 minus 2, 540 divided by 5. This is for the pentagon. Then we have 108 degrees. So all of these angles right here that I'm putting in green will be 108 degrees, right? 108 degrees, which is crazy if you think about it, right? It's crazy. So now, if we have just the blues, right? Hexagon will equal 120 each. Amazing. Yes, that's correct. Each of the hexagons will be 120, right? 120, because a hexagon will have 720 degrees divided by 6, and that is equal to 120 degrees. So everything I put in red here now will be 120. Now, do you notice this little shape that we have in the middle? How many sides is this middle shape that I'm outlining with my pen here? How many sides is this little weird looking skinny shape in the middle? How many sides is it? We have 1, 2, 3, 4, and 5, right? We have 5. We have 5 sides. So we know that for a polygon with 5 sides, the interior angles add up, great star, it adds up to 540. We just found that. So 540 is going to equal x plus, in red, we have 2 angles, 540, great, Chloe. So 120 plus 120 plus the green ones, plus 108 plus 108, right? 108, 108, we have 120, 120. So as soon as we started the problem, that's all we needed, right? And we can find this x. We add these all up, and voila, magic. 120 plus 120 is 240, plus these two, that's 216. That's 456 total. So x will equal plus 456 degrees, 540 degrees. X will equal, that'll be 84 degrees, just like that. How did you get 720 and 540? Great question, Kushi. The 720 I got because I know a regular hexagon, if I were to color code this, a regular hexagon has 6 sides. And so I used 180 times 6 minus 2 to get 180 times 4, which is 720 degrees. For the green ones, I did the same exact thing, right? We're putting everything together. Everything we know, we are putting together right now. I did 180 times 5 minus 2 is equal to 180 degrees times 3, which is equal to 540 degrees. Hopefully that made sense. Amazing stuff, y'all. I have one last question, and it's an application question. And have y'all heard of the SAT before? That's what we're in for today. How many sides does a polygon have if the measure of each interior angle is 5 times? The measure of each interior angle is 5 times the degree measure of the exterior angle. Okay, let's draw that out. So here is, let's say, an interior angle. Here's the interior angle. Interior angle. And let's say in red, we have here the exterior angle. What do we know about the sum of these two angles? Can anyone tell me in the chat? The sum of an interior and exterior angle of any polygon, what is that going to equal? The sum of any interior angle and an exterior angle, what will that equal? 180 star, amazing. 180 is correct. We have 180 degrees. Now, what do we know? We know that each interior angle is 5 times the degree measure of each exterior angle. So let's say our exterior angle, let's call it x. Can anyone tell me what the value of our interior angle will be if our exterior angle is equal to x? Oh, a straight line, exactly, right? A straight line equals 180 degrees. Awesome. If our exterior angle is x, and we know that the measure of each interior angle is 5 times that, what could we call our interior angle? Our interior angle we can write as equal to 5 times the measure of each exterior angle. So we can write that as, since we know exterior angle is equal to x, we can say the interior angle is equal to 5 times x, or in other words, 5x. So we have 5x plus the exterior angle x, and that gives us 6x is equal to 180 degrees, and this part's easy, right? X is equal to 30 degrees. Awesome, Chloe, I see you. So x is equal to 30 degrees. Well, now I know x is equal to 30 degrees. How do I find the measure of how many sides the polygon has now that I know an exterior angle is 30 degrees? Right? This part was really easy, remember, right? Before. What's the sum of all exterior angles in a polygon? All the exterior angles of a polygon, we saw the animation, all of them add up to a little circle, which is how many degrees in the circle? I'm just trying to recreate that animation. I look really funny in my on the screen. 360, yes, E. 360 degrees, yes, Star. 360 degrees. And we're going to divide that by 30 degrees to get 12 sides to this polygon. Chloe, I see you got the answer really early. Kushimuki, awesome. Danu, awesome. Great work today. That was our last question. So now, if you're still here with me, put a plus in the chat. And while you do that, put a plus in the chat, call your parents, call your guardian, call whoever adult is near you, because I have something very special to share with you all today. Put a plus in the chat if you're still here or if you enjoyed today's lesson. I see you, Star, Danu, Kushi, Chloe, Hasana, amazing. Yi, I see you. All right, let's take a look. I want to share something really special with you. Chloe, I see you as well. Samiha, awesome. Our lesson may be ending today, but your progress doesn't have to. The My EdSpace Geometry full year course starts on October 6th. So in just about a month, our course, my course with My EdSpace Geometry starts on October 6th. You're going to get 2 engaging live and interactive lessons each week, just like the one you got today. You're going to be getting that twice a week, each week. Video recordings to revisit lessons. Let's say you couldn't make today's lesson. It'll be recorded. It's being recorded right now, actually, and you'll be able to access it later on as well. Professionally designed workbooks. I don't know if you were able to use your workbooks today, but it was emailed to you before today's session. These workbooks you can use as graphic organizers to follow along in the lesson, and they're professionally designed for every single lesson. You have practice with exam-style questions. You're not getting that today, but after every lesson, you're going to get practice. And for that practice, the solutions will be made by me in a video that you can watch me doing all the problems so that you have all the answers. You can get all your questions answered through these detailed video solutions. But how much is it? For context, when I used to be a private tutor, guess how much I used to charge per hour? In the chat, guess how much you think I charged any student at any level per hour? How many dollars do you think I used to charge my students for each hour that they had with me? Tutoring, anything. Oh yeah, the workbook for today's lesson is also in the lesson description. Thank you, Venny. $17, $30, $50. Wow, all very, very good guesses. I actually used to charge a minimum of $100 per hour. 120, Mookie, closest one. $50, yeah. I used to charge a minimum of 100 all the way up to $200 per hour. Now, the thing with private tutoring is that families always have to choose between what works and what they can afford. Effectiveness versus affordability, right? They always have to choose one, but never both. And that's why we created My EdSpace. You get all this, right? 60 total lessons, by the way, for the entire school year for each course. We meet twice a week, an hour each. All lessons are recorded, professionally designed workbooks for you to follow along, practice questions with detailed video solutions, not just answers in the back of the book, but I'll be solving every single practice problem on the screen so that you can check what you got right, what you got wrong, where you need more help, anything like that, with little gems in there as well, some tips and tricks for studying. All that for $99 a month, which is 8 times cheaper, right? In a month or 4 weeks, if I were doing this as part of tutoring, I'd be meeting with this student 8 times a month. That'd be $800. But $99 a month, that's all it takes. Why stop there? Because you're here today, I'm offering you a special limited time offer. 20% additional discount on our annual package. To protect you from any risk, we provide a 30-day risk-free full refund guarantee as well. 30 days to check it out, and you get a full refund if you do not like it. However, this is a first come, first serve. Spots are getting taken as we speak. This is a limited time offer. So if you're interested, text me. Code word START to this number on your screen. Scan this QR code. It'll take you straight to my number. Code word START. You're going to be messaging with me. Yes, this is my number. You can text the code word START. If you're interested in this course, if you want to study with me, if you want to start your journey with me at my EdSpace and continue to learn, grow, become a master at geometry. This simple. Scan this QR code. Take a picture if you don't have your parent, guardian near you or any adult that needs to look at this. Take a picture of it. You can send me code word START to this number, and we can start your journey with me at my EdSpace. Everything will be done by me. You'll be working with me. So if you enjoyed today's lesson, I would love to work with you. I would love to continue to teach you and guide you and just learn alongside you. So this is it. If you have any questions, I'll be here for a couple more minutes. Ask away. But otherwise, if you found today fun, if you enjoyed today's lesson, scan this QR code or text the code word START to the number on your screen. Thank you everybody for your time today, and I look forward to talking to you through text. I hope you had fun today, everyone. Love the energy today. Chloe, Mookie, Kushi, Samiha, Danu, Purple VR, Yi. Wow, there were so many of you today. It was awesome. Really looking forward to seeing you all again. Again, the courses start October 6th, twice a week, Mondays and Wednesdays, 6 to 7 p.m., just like we met today, Pacific time. I'll be looking forward to your text, and I'll speak with you soon. Thank you, everyone.